go through Java comparator versus comparable. If you recall from your lectures before where we talked about collection, there was a comparable methods. Let's go through the main differences. Let's just start up with comparator. Both comparator and comparables are interfaces in Java. You have to import them for you to use. The difference between the two is comparator comes from Java util, whereas comparable comes from Java Lang. But because Java Lang is already included in your native Java SDK, this is already done. The only difference between the two is that for comparator, you have to import the comparators here. We like to compare two objects. These two objects could be student, could be players, or it could be a game piece. Let's just say there's a student class, and this student class is very easy. It's got the student's age and name. We want to compare student's age. So you have multiple students out there that you want to make comparisons to. Just write up a comparator, use comparators overwritten methods called compare to compare their age. Or you can use comparable, but in that case, you have to use the compare to methods. So let's just write out the whole domain class. This domain class called student. In order for us to get started, let's just create a student's class. Let's say the student's class is name as well as the student's age. Age is integer. The student has a custom constructor called name and an integer age. Upon instantiation, we want to set both this student's object's name and this student's object's age, and making sure that we can actually run it. Let me just say we have two students. One is called Joe. This Joe has a name called Joseph, and the age is 19. We want to just create another name, another student's instance, and this student's, her name is Anne, and her age is 20 for sanity check. See if there's anything wrong with it. This has to be a string, obviously. Let's run this again. Now this works. For Java interface comparators, this is a concrete class we have to write. Let's just call this comparator age comparator because we're comparing ages in students. This comparator implements comparator. So this comparator is from the Java util comparator. And because we're using a student's object, the stuff that's being compared is a student's object. So we have to use student generic. You have to also implement its requisite overridden methods. It calls compare. Two students object we're trying to make comparisons to. Ultimately, you can have a logic saying if age 1 equals age 2 from both students, they're the same age, then return 0. If student 1 is older than student 2, you say 1, return 1. Else, return -1. And that number is either negative, 0, or positive. Positive, I'm just going to call it 1. Negative, I'm just going to call it -1. If S1 age equals, we're comparing an integer against the integers, then return 0. Else, if S1 age is greater than S2 age, I want to return 1. Else, return -1. So ultimately, your choice, whether you want to return 1000 instead of 1 or return -2 versus, right, doesn't really matter. There's lots of sorting algorithms out there makes use of this compare methodology, has a logic in the system that calls for whether this is 0, positive number, or a negative number. If you just want to make use of this comparator, then it's very simple. You have to instantiate it. Age comparator. This whole object is called comparator. And you can do age comparator like this. You don't have to really pass in students because students are already done here. Student is a generic variable, and this generic object is being passed in there in construction time. And because students already defined right here, there is no confusion for line 25 as to where the student's object is. Once you instantiate at line 10 a comparator, you can do a comparator compare. Student 1, which is Joe, against student 2. This compare returns the integer, so we can just do a check. We know that Joe is older than Anne, so the answer is should be 1. This sort of comparison is very useful when you have a sorting algorithms in place. Joe is younger than Anne, So the answer is -1. Let's just say we want to convert this problem all the way to using a comparator. Well, forget about comparators here, right? So we got rid of our comparator object here. The difference between the two is you're going to have to modify the domain object. You're comparing the primary domain object against the secondary one. So you have to implement comparable. And this comparable actually takes students as well. There's another method you have to write. This domain object has to be completely overwritten. Integer compare to. This compare to, it's got another student instance that you'd be comparing to. And because the age is an integer, so if you simply just want to compare the age and see which one is bigger or not, you can use the integer class. Integer class compare has the same methodology that calls for the same exact logic that we have here. Ultimately, you can do the integer comparisons that way too by converting this into the same thing as I have here. I'm just going to return this entire students object. Student object has an age element in it. This is this students compare with the other students' age. Line 32 to line 34 could be replaced with this as well. Students 1 age and students 2 age into the integer compare. Obviously, we have to take this out because that's what's our comparator. Joe compared to. Joe is the student's object that implements comparable, and then you're doing comparisons compare to. And this compare to returns an integer. So we're going to do a string system out print line. Give us a -1 because Anne is older than Joe. And the lessons here is lots of times your domain object, which is students here, if the domain object should not be modified, sometimes you just don't have the logic to do that. You can just leave it as is and use what's called the comparator. Comparator is very useful in that regard because it does not change your underlying domain objects. Using the comparators also allows us to avoid additional code to our domain classes. So we can define basically like multiple different comparison strategies. Depends on whether the domain class could be modified or not. If not, then it's perfectly okay. Just write a standalone class to do a compare. That class implements this domain object as a generic to do the comparisons. And your compare is something that you can modify yourself. So this wraps the overview on the comparator and comparable.